So today what we're doing is inequalities, or rather triangle inequalities. So, triangle, why is that doing that? Triangle inequalities. Now, just for the algebra-like review, what would I do if I had negative 2x plus 5 is less than, let's say, 14? What would we do to solve that?
Subtract the 5.
Okay, we subtract the 5, and we get 9. I have negative 2x is less than 9, then what do we get?
Divide by negative 2x, but the sign would switch.
Yeah, when I divide by a negative with an inequality, it flips around and I get negative 4.5. Okay? Now, that's a brief review of an inequality and what it is. We need to note that this means less than. We always read left to right. I don't understand why people have a hard time with this, but you know, you read left to right. So the thing on the left is smaller than the thing on the right, and this is greater than. Again, because the thing on the left is bigger than the thing on the right. So we have less than and greater than. Well, what does this have to do with triangles? So I'm going to go ahead and erase this little equation here, because really not what we're doing. It's just to illustrate that we could solve equations with this. Let's say I have a triangle, and I'm going to exaggerate this wonderful little triangle right here. And I want you to note my angle A right here. And I'll have the side BC. Sure. Look at my diagram, please. All right, so here's my triangle. Which angle appears to be the smallest?
BC.
A.
The smallest angle is angle what?
A.
A. And that one's pretty obvious because I drew it to be very obvious. Everyone see that angle A is the smallest angle.
Yep.
Okay, now what's the smallest side?
BC.
Say again.
BC.
BC. So side BC. Now let's just take note of this. You said this was the smallest angle, and you said this was the smallest side.
So the smallest side is opposite of the smallest angle?
Yes. Exactly. That is the entirety of this lesson, is that the sides and angles go in order. So the smallest side is opposite the smallest angle. Okay, so if you can understand that, then obviously the largest side is opposite the largest angle. Alright, so here's the reality of what you'll be given. Here's a triangle, and maybe I give you 60 degrees here, 50 degrees here, X degrees right here, and I'll call this triangle ABC, and I'll say put the sides and angles in order from smallest to biggest. Alright, so I'll have my angles over here on the left, and I'll have my sides over here on the right. I'm going to have to actually know this angle first, so what should I do?
Add 60 and 50 and subtract it from 180.
Okay, so I have 180, I subtract the 50, I subtract the 60, that's 110, so I have 70, so X is 70.
70.
Okay, so what is the smallest angle?
B.
Angle B, okay, is less than, you're going to want to leave some space here. Now let's think of the side. Then what side is the smallest? Segment what?
AC.
AC must be the smallest side, is less than. Now, what's the next biggest angle?
A.
Yeah, so angle A is the next biggest. which means which side is the next biggest?
BC.
Segment BC. All right, then less than. What is the largest angle?
C.
So C.
So angle C, which means which side is the largest?
AB.
Side AB. Any questions on how we put together those inequalities?
No.
Okay. The next thing, okay, related. In any triangle, the sum of two sides must be greater than the third side. And if that's not the case, then you do not have a triangle. So what am I saying here? Let's say this side's 10. Let's say this is 6. And let's say this is 2. Now, given I don't have rulers or anything right here to show you, but do you see that for this side 6 and this side 2 to actually meet, they'd have to be longer than 10? If I were to try to get these to meet, I would see that I'd have to rotate them down, and then I'd rotate them down, and then I'd have a space of 2 units in between them. Does that make sense?
Yes.
As in, pretend this is on a hinge, Justin, and I'm asking you, is this a triangle? Now, obviously, I would just draw the triangle and say, I'd be like that. But the reality is, 6 plus 2 is how much?
8.
8. These two sides together are not long enough to actually meet. Because this is 10, right? So the sum of two sides has to be greater than the third side. 6 plus 2 is not greater than the 10. If you don't believe me, take a piece of wood that's 10 inches long and attach to it on a hinge a piece of wood that's 6 inches long, and then over here another piece of wood that's 4 inches long on a hinge, and see if you can get these, well, I said 2 inches, right? Not 4. See if you can get these to meet in a triangle if they're on a hinge.
You wouldn't be able to.
You would not be able to. You would not form a triangle. They'd just lie flat and be dangling there. So it would not work out.
Okay.
So if a shape is a triangle, add the two shorter sides and make sure it's bigger than the longer side. I don't need to waste time adding the two longer sides because obviously their sum's going to be bigger than the smaller side. So this really applies, although it applies to any two sides, really the one that we need to worry about are the two shorter sides. So if I draw a bunch of triangles up here, I want you to tell me if they're actually possible triangles or if they are not possible triangles. Do it right in your notes. You can draw the triangles or you can list the sides. So I have 3 triangles here. Are these actually possible triangles?
And we use, excuse me, and we use what you just said about the two sides have to be greater than the third side in order to figure out if it's an actual triangle.
Yes.
So the two smaller sides
Smaller
on there, add those
have
two.
to add to be bigger than the longer side. So on this one, this first one, is this a triangle?
Yes.
Yes. Why? Because 9 plus 10 is greater than 11. How about this other one? Is this a triangle? No, it is not, because 6 plus 8 is not greater than 14. Why? Because 6 plus 8 is 14. So that's not possible. This would be a line. You might say, but you drew a triangle. Does not matter. It matters how it's marked. So that's not. How about this third one?
No.
No, this is not a triangle. Why? Because 6 plus 7 is not greater than 14. And how about this last one?
Yes.
Yes.
Yes, this one is. Why? Because 7 plus 6 is greater than 10. Pretty simple to test those sides, right? The sum of the two shorter sides. So short side plus short side
Has to be larger.
has to be greater than the longest side. Now, if they're the same length, that doesn't matter. One side will be short. Now, if they're all the same,
Did they just
you
like
guys
help each other?
paying attention over there, goofing off. Pay attention. So what if they're all the same size? 10, 10, and 10. Well, choose two. Is 10 plus 10 greater than 10?
Yeah.
Yes. Okay, so is this a triangle? Yes. Okay, it doesn't matter which ones you choose. What if I had 10, 10, and 4? This is an isosceles triangle. Well, I choose the two shorter sides. Now, these two are not the two shorter sides. These would be two shorter sides. Doesn't matter which 10 I take. Is 4 plus 10 greater than 10?
Yes.
Yes. So that's a triangle. Any questions on that? Any questions on the angle inequalities where I know the sides?
Kinda.
Okay. This is 10. This is 8. And this is 6. Here's angle A, B, and C. Put the angles in order.
Okay.
From smallest to biggest. What is the smallest angle? Coleman.
A,
Angle A. How do you know?
because is the smallest angle is opposite of the smallest side, and
Yes.
6 is the smallest side.
The smallest angle is opposite the smallest side. How about the next biggest? Evan.
C.
Angle C. Okay, because 8 is the next biggest side. What then? Well, then obviously angle B is left. Notice I used all less thans. Okay. See, those are opposite. All right, we are really on the last thing that goes with this section of triangle inequalities, and that's going to be find the range of possible third sides. All right, so let's say I have sides 4, 7, and x. And I want to know, well, if this is a triangle, it's a triangle, well, what could this possibly be? So I have two possibilities. These could be the shortest sides. Okay? If those are the shortest sides, that means x would have to be at least 11. Okay, because I'd add those two. Or the 4 and 7, this could be the longest side. Well, if that's the longest side, then x would have to be less than 3. Because the sum of the two shorter sides has to be
Greater.
greater. Should that have been greater?
Yeah.
That should have been greater than.
See, that's one question.
Wouldn't x have been less than 11 then?
And yes, x should have been less than 11. Thank you. I mixed those up. My bad. Good job. Keep me honest. Yeah, x would have to be greater than 3.
It has to be greater than 4 because it can't be equal, you said.
It could be 3.1. Okay? So it's greater than 4. I didn't say it could be equal to. So how are we going to do this, like, with ease? It's the same question. Let's say I had 5 and 12. Okay? And I want to know what could x be. Well, here's what I'm going to do to make this short. I'm going to put x between two things. I'll subtract those numbers. That's going to account for if these are if this is the longest side. So that would be 7. So x has to be bigger than 7. Then I'll add these two sides. That accounts for this being the biggest. See how I get that? So those are the range of possibilities for x to be. What if I had 12, 18, and x? What are the range of possible sides?
What, 61?
Oh, yes.
30.
Okay, I subtract them, 6.
30.
I add them,
3.
30.
Yeah.
X is between 6 and 30. I subtract them and add them. That gives me the range of possible sides.